Okay, Specialist Mathematics, external paper, paper 1 tech free, 2022. We're going to do question 19. Okay, my video got interrupted earlier, so I'm on just blank paper. So here we go. This is an integral question. We've got the function goes through the origin, so that's a good bit of information for, we'll go like this, so closer, for our plus c. We are told that the gradient of the function fx is defined by g of x equals e to the x sine to the negative 1 ex. Determine f of x. So f of x is going to be the integral of e to the x sine negative 1 e to the x dx. We're going to do this by parts. When I do my by parts, f of x equals sine negative 1 e to the x. My g dash x is e to the x, so my g is e to the x. I know people use u and v, depending on what you're more comfortable with. If you want to use u and v dash and etc. And now I need to derive this. It's not a straightforward derive because x is the power. So you'd have to use chain rule. So if I said, let y equal sine to the negative 1 of u, where u equaled e to the x, and dy du is 1 on square root 1 take u squared, and du dx is e to the x. So to y dx is multiplying these two things. It's my chain rule. I'm going to get e to the x over square root 1 take e to the 2x. Because my u squared and u is e to the x, so that's where I get the e to the 2x. So e to the x over square root 1 take e to the 2x. So that was just my working out my derivative there. Using my by parts, to integrate this, remember it's going to be that times that, take away the integral of that times that. So it's e to the x sine negative 1 e to the x, take away the integral of e to the x over 1 take e to the 2x by e to the x dx. So that's e to the 2x on the square root of 1 take e to the 2x dx. So we've done our by parts, and we get to this point and we go, okay, we've still got quite a complex integration to happen here. And we're going to use substitution. You could have, with this question, done substitution first, but then you still would have needed to do further integration as well. This is a complex question. So we've used by parts, and then we're also going to have to use substitution. Sorry, I'm just having trouble with my paper. Oh, man. Because what I'm going to do is I'm going to just look at that integration. It's e to the 2x, 1 take e to the 2x dx. Let's just take it out of the other one and work on it itself. And we're going to do it by substitution. I'm going to let e equals 1 take e to the 2x. Sorry, I think I said that incorrectly. I'm going to let u equal 1 take e to the 2x. Then du dx, I'm deriving, so the 2 multiplies down in front, so I get negative 2 e to the 2x. So du over negative 2 e to the 2x equals dx. So that's my little bit for that. So this integral is going to equal e to the 2x over the square root of u times my dx is du over negative 2e to the 2x. The e to the 2x's cancel. I'll bring this negative 1/2 outside. That's u to the negative 1/2 du. Because it's on the denominator, it's negative. That's negative 1/2 u to the 1/2 divided by 1/2 plus c. Because I've added 1 to my power, divided by my new power. These halves will actually cancel. Gives me negative u to the 1/2 plus c, negative square root 1 take e to the 2x plus c. So using substitution, I get that. So now I'm going to go back to my first bit of paper. Oops. And so that's e to the x sine negative 1 e to the x minus negative square root 1 minus e to the 2x plus c. So this integral I worked out over here by substitution, and I sub it back across. So this is where I'm working now. So that's e to the x sine negative 1 e to the x plus the square root of 1 minus e to the 2x plus c. So this is my f of x. I need to find the exact solution. I was given a bit of information to find c. I'm going to say it goes through the origin. So f of 0 equals 0. So 0 equals e to the 0 sine negative 1 e to the 0 plus square root 1 take e to the 0 plus c. E to the 0 is 1. And then, so that's 1 take 1 plus c. So that's going to go to 0. And I'm going to c equals negative sine negative 1, 1. If we remember our little sine graph, goes like this. So where is sine 1? It's at pi on 2. So c equals negative pi on 2. Putting it all together, f of x is equal to e to the x sine negative 1 e to the x plus the square root 1 minus e to the 2x minus pi on 2. That's my final. So my jump down from here, I just substituted in c, and we're done. That's it.